Hello students, in our previous class we learned about sequence and series. Then some special kind of sequences, one of them is AP. Okay, in this class we will learn how we can solve AP related problem. Okay, so here we choose these 5 problems. In these 5 problems we will learn how we can recognize AP through its problem. Okay, so let us solve problems. So in first problem it is given that 8th term of an AP is 31. That means there is an AP whose 8th term is 31 and its 15th term is 16 more than its 11th term. Okay, so here it is given that 8th term of an AP is 31 and its 16th term is 11 and its 11th term is 16 more than its 15th term. We have to find the AP. So to find an AP we have to know its first term and common difference. That is why first of all we have to let its first term and then common difference. Okay, solution 1. Given 8th term of the AP, that is A8 is 31 and its 15th term is, that is A15 is 16 more than its 11th term. Okay, so in the first problem 8th term of the AP is given, which is 31 and its 15th term is 16 more than its 11th term. Okay, so this is the given thing. Let first term of the AP be A and common difference be D. Okay, so therefore A8 equals to 31 imply A plus 8 minus 1 into D equals to 31, because already we know nth term of an AP, that is AN, is equals to first term A plus n minus 1 into D. Okay, so by this formula we can write A8 is equals to A plus 8 minus 1 into D, which is equals to 31. From this we can write A plus 7D equals to 31. This implies A equals to 31 minus 7D. This is the first relation. Okay, so from the given thing we get A is equals to 31 minus 7D. Again A15 equals to 16 plus A11 imply A15 means A plus 15 minus 1 into D by following this formula equals to 16 plus A11 means A plus 11 minus 1 into D by following the same formula we get a plus 14d is equals to 16 plus a plus 10d. Now if we bring a and d term, that is a plus 10d in the left hand side, we will get a plus 14d minus a minus 10d equals to 16. We can cancel this a. Then 14d minus 10d will give 4d, which is equals to 16. This implies d equals to 16 by 4. Cancelling this 16 and 4, we get d equals to 4. Okay. So from the second condition, that is its 15th term is 16 more than 11th term, we get a15 is equals to 16 plus a11. Simplifying this, we get d equals to 4. That means common difference of this AP becomes 4. Now putting d equals to 4 in 1, we get a equals to 31 minus 7 into 4. That is, or this imply a equals to 31 minus 28. This imply a equals to 3. So thus we get the first term and the common difference of this AP. Okay. So the required AP is a plus d, a plus 2d, a plus 3d, continuing, equals to 3 plus 4, 3 plus 2 into 4, 3 plus 3 into 4, continuing. 3, 7, 11, 15, continue. Okay. So this is the way by which we can find this AP. Okay. In problem number 2, it is given that means an AP is given. The AP is minus 1, 3, 7, 11, continuing. Okay. Here an AP is given. We have to find which term of this AP is 95. That means we have to find the number of term of a value of this AP. The given solution 2. The given AP is minus 1, 3, 7, 11, continuing. Okay. So first term, that is A, equals to minus 1. Common difference D is equals to 3 minus of minus 1. That is 3 plus 1. That is equals to 4. Already we know the definition of AP. By the definition of AP, we can find the common difference of an AP. Okay. So that is why to find the common difference of this AP, we subtract first term from the second term. That is from the definition of AP, when we have to find its common difference, then we have to subtract any term of that AP. We have to subtract any term of an AP from its previous term. Okay. Sorry, by the definition. Sorry, from the definition of AP, when we want to find the common difference of an AP, then we have to subtract previous term of an AP from its succeeding term. That is, when we want to find the common difference, then we have to subtract A3 from A4 or A4 from A5. Okay. So, by that way, we find the common difference, that is here 4. Let nth term of this AP be 95. So, therefore, nth term is denoted by an equals to 95. So, these imply an means a plus n minus 1 into d is equals to 95. These imply putting the value of a and d, we get minus 1 plus n minus 1 into 4 is equals to 95. Which imply n minus 1 into 4 is equals to 95 plus 1. Minus 1 when goes in right hand side, it becomes plus 1. So, n minus 1 is equals to 95 plus 1 means 96. 96 by 4 will give 24. Thus, we get n equals to 24 plus 1. That is n equals to 25. Okay. So, we can say, so thus we can say that 25th term of this AP is 95. There are some such kind of problem where some AP, where we have to given some AP and we have to find, we have to check whether some certain certain terms belongs to this AP or not. Okay. So, in those kind of problem, we have to follow the same procedure. If the value of n is a natural number, then we can say that number is belongs to one of the term of that AP. Otherwise, that number will not be the term of that AP. Okay. So, this is the way by which we can solve problem number 2. Solution number 3. In problem number 3, we have to find the middle term of this AP 6, 13, 20 continuing up to 216. Okay. So, to find the middle term of this AP, first of all we have to know number of terms of this AP. That means how many terms are present in this AP. Okay. So, before finding the middle term, we have to know about some concepts about the middle term. Okay. Suppose there are some objects. They are like this. Okay. So, here we choose 5 objects. So, within these 5 objects, which object is the middle object. Okay, so middle object or middlemost objects are that or those number of terms which has equal number of terms in its left and right. Okay, this is the middle term. Because it has two objects in its left and two objects in its right. That is why we can say this is the middle term. Similarly, if we choose these six objects, then there is no specific middle term. That means there is no single middle term, because there is no particular term which has equal number of terms in its left and right. Okay, so in this case we have we can get a pair of middle terms. Because for this pair, its left side contains these two objects and its right side also choose two objects. Okay, so middle term or terms is or are that or those object or objects which has equal number of terms in its left and right. So this is the way by which we can identify middle term or terms. Middle term or terms is or are that or those number of terms which has equal number of terms in its left and right. Okay. So in the first case, the total number of terms is 5. Case 1, total number of total number of terms equals to 5. So middle term is third term, that is 5 plus 1 by 2 eighth term. So in case 1, total number of terms is 5, so its middle term is third term, 1, 2, 3. So third term is its middle term. So how we get this third term? By the division of total number of terms plus 1 by 2, that is 5 plus 1 whole divided by 2 eighth term. In general, if an AP consists an odd number of terms, say n, then it has only one middle term, which is n plus 1 whole divided by 2 th term. Okay. So case 1 give us the concept about middle term. That means when total number of terms is odd, then how we can find its middle term. That means if total number of terms is odd, then there is only one middle term, which is n plus 1 whole divided by 2 th term, where n is the total number of terms. Okay. In case 2, total number of terms is 6. That is why we get 2 middle terms. Case 2, total number of terms equals to 6. So, middle terms are third, and fourth terms. In general, if an AP consists even number of terms, say n, then it has two middle terms, which are n by 2th term and n by 2 plus 1 8th term. Okay. By following this example, we can write total third term. Third term means 6 by 2 8th. That is third term. And fourth term means 6 by 2 plus 1. 3 plus 4. Okay. So, when depending upon the number of terms, we can identify how many middle term or terms an AP consists. Okay. So, if there is odd number of terms, then that AP has only one middle term, which is n plus 1 by 2 th term, where n is the total number of terms of that AP. Okay. Again, if an AP consists even number of terms, then it has two middle terms, which are n by 2th term and n by 2 plus 1th term, where n is the total number of terms. So to find the middle term of this AP 6, 13, 20 continuing up to 216, first of all we have to find number of terms of this AP. The given AP is 6, 13, 20 continuing and the last term is 216. First term A is equals to 6. Common difference D equals to 13 minus 6, that is any term minus its previous term. This is A2 minus A1. 7. Let 216 be the nth term of this AP. Okay. So therefore AN is equals to 216. Imply A plus N minus 1 whole into D equals to 216 by the general formula of AN. Now putting the value of A and D, we get 6 plus N minus 1 into 7 equals to 216. So N minus 1 whole into 7 is equals to 216 minus 6. This will give N minus 1 is equals to 216 minus 6 will give 210 whole divided by 7. Cancelling these two, 210 and 7, we get 30. So N is equals to 30 plus 1. This will give N equals to 31. Okay. So the given AP consists 31 terms. Since the number of terms of this of the given AP is odd, therefore there is only one middle term which is (31 plus 1 whole divided by 2 eighth equals to 32 by 2 eighth equals to 16th term of the AP. Okay. So after finding number of terms of this AP, we observe that total number of terms becomes 31, which is an odd number. So since when an AP consists odd number of terms, then it has only one middle term. Okay. So in this AP there is only one middle term, which is 31 plus 1 whole divided by 2 eighth term by following this formula. So thus we get 16th term of this AP is the middle term. So therefore A16 equals to A plus 16 minus 1 whole into D equals to A. Now we can put the value of A and D. A means 6 and D means 7. So 6 plus 6 plus 15 into 7. 6 plus 15 sevens are 105. 111. So 111 is the middle term of this AP. Okay. So this is the way by which we can find the middle term of an AP. So to find the middle term of an AP, first of all we have to know its number of term, and then by following this process we can find its middle term. Okay. In problem number 4, it is given that A1, A2, A3 continuing up to AN are in AP. That means there are in numbers of terms, they are like A1, A2, A3 up to AN, which are in AP. We have to prove that 1 by root over of 1 by root A1 plus root A2 plus 1 by root A2 plus root A3 plus continuing plus 1 by root of A of n minus 1 plus root an is equals to this. Okay. So given A1, A2, A3 continuing an are in AP. Required to prove one by root A1 plus root A2 plus 1 by root A2 plus root A3 plus continuing plus 1 by root over of A of n minus 1 plus root over of A of n is equals to n minus 1 whole divided by root A1 plus root AN. Okay. So this is given, that means these n numbers A1, A2, A3 up to AN are in AP, and we have to prove this thing. Okay. Since A1, A2, A3 continuing AN are in AP, therefore by the definition of AP we can write A2 minus A1 equals to A3 minus A2 equals to A4 minus A3 equals to continuing equals to an minus of an minus 1. Okay. That means by the definition of AP, it's any term minus its previous term always gives a fixed value. So by that definition, we can write A2 minus A1 is equals with A3 minus A2 equals with A4 minus A3 continuing, and then equals with an minus of an minus 1. So this equal figure we let as D. So LHS becomes here we consider A2 is greater than A1. So to rationalize this, root A2 plus root A1, we have to multiply numerator and denominator by root A2 minus root A1. Similarly, rationalize its denominator. We multiply its conjugate with numerator and denominator. Okay, now we rationalize these denominators individually. So numerator becomes root a2 minus root a1, and this becomes the formula of a square minus b square. By following this formula, x square minus y square is equals to x plus y into x minus y. So by following this identity, we can write the denominators as. So this becomes root a2 minus root a1 by a2 minus a1 plus root a3 minus root a2 by a3 minus a2 plus continuing root an minus root an minus 1 by an minus of an minus 1. Now we can put a2 minus a1 as d, a3 minus a2 as d. That means we can replace these denominators by this common difference d. So after replacing, we get root a2 minus root a1 by d plus root a3 minus root a2 by d plus continuing plus root an minus root an of n minus 1 by an minus a of n minus 1. Sorry, this is also by d. If we take 1 by t as a common factor, then this becomes root a2 minus root a1 plus root a3 minus root a2 plus continuing plus root an minus root of a of n minus 1. Now we can cancel root a2 plus root a2 minus root a2. And if we proceed this way, then there will be only root over minus a1, sorry, there will be only minus root of a1 and plus root of an, because there is no pair of these two terms. Thus we get 1 by d is equals to root an minus root a1. Now we can multiply its conjugate with both numerator and denominator, like this way. Multiply this by this and then balancing this. Okay. So this becomes root n whole square minus root a1 whole square. And in the denominator it becomes root a1 plus root an. By following this formula of x square minus y square, that is x minus y into x plus y is equals to x square minus y square. So root an minus root a1 by root a1 plus root an. An means the nth term of this AP, which is equals to first term, that is a1 plus n minus 1 into d. Here we consider d as the common difference. So n is replaced by a1 plus n minus 1 whole into d minus a1 whole divided by root a1 plus root an. Cancelling this a1, we get 1 by d into n minus 1 into d by root a1 plus root an. We can cancel this d from numerator and denominator, and then finally we get n minus 1 by root a1 plus root an, which is our right hand side item. So this is the way by which we can prove this left hand side item. Okay. In problem number 5, it is given that A, B, C, that means these three terms form an AP. Okay. So if ABC are in AP, then we have to prove that these three numbers or these three terms will also be in AP. Okay. So let us study how we can prove these three numbers are in these three numbers forms an AP when ABC are in AP. Since ABC are in AP, therefore 2B equals to A plus C. Then 2B equals to A plus C. Okay. In our previous class, we learned when ABC are in AP, then how we get 2B equals to A plus C. So since ABC are in AP, then we have 2B equals to A plus C. So to prove these three numbers are in AP, to prove A into 1 by B plus 1 by C, B into 1 by C plus 1 by A, C into 1 by A plus 1 by B, it is sufficient to prove this plus this is equals to twice of B into 1 by C plus 1 by A. Okay. So to prove these three terms are in AP, it is sufficient to prove this plus this. They are like also A and C. So if we prove this plus this equals to twice of this, then we can say these three numbers are in AP. Now A into 1 by B plus 1 by C plus C into 1 by A plus 1 by B equals to A by B plus A by C plus C by A plus C by B. So we multiply these terms. A by C plus C by A plus A by B plus C by B. Here we accumulating these like denominators B in this way and arrange this term as, that means 1 by C plus C by A plus A by B plus C by B. Then adding the first two terms, here AC becomes the LCM. So in the numerator we get A square plus C square, and for this last two term B becomes the denominator LCM. So in the numerator we have A plus C. A plus C is equals to 2B from this given. So we can replace this A plus C by 2B. Cancelling this B, we get A square plus C square by AC plus 2. So nothing is in the denominator means 1 is in the denominator. So after finding the LCM of this denominator, we get AC becomes the denominator, and in the numerator we get A square plus C square plus 2AC. Okay. So this will give the identity of x plus y whole square. So by following this identity, x plus y whole square is equal to x square plus y square plus 2xy, we can write this as A plus C whole square by AC. And now we can write this A plus C whole square as A plus C into A plus C. Then we bring AC as its denominator. So we replace this A plus C by 2B, and distributing this we get A by AC plus C by AC, and cancelling this A and this C, we get 2B equals to 2B into 1 by C plus 1 by A. Okay, so this is the way by which we can prove this summation, that is A into 1 by B plus 1 by C plus C into 1 by A plus 1 by B is equals to 2 into B into 1 by C plus 1 by A. This implies A into 1 by B plus 1 by C, comma B into 1 by C plus 1 by A, comma C into 1 by A plus 1 by B are also in proved. So in this class we learn how we can solve these 5 different kinds of problems. Okay. So in our next class we will learn more things about AP.